Hello, a couple of days ago I decided to do a series of tests on my photovoltaic system, mostly on the batteries. So I did some analyses with the DEWESoft series and with the DCCT, and I did this to see how the battery voltage and current charging and discharging them, and see how they're related. These are the batteries that I measured, and this is also the test setup. We had different issues, but luckily we were able to solve all of the batteries are connected in series using these aluminum profiles, bus bars. They're connected with bolts, obviously, and since we saw problems that the batteries were all at different voltages after a couple of days, we decided to mount this equalizer, and since then everything seemed relatively good. I decided to do this test because first I was curious really how much of a difference the equalizer made, and second, the test should in theory also be able to be used to measure the capacity of the batteries, since by knowing the current, which is of course measured by the DCCT, the voltage with which we know how charged the batteries are, it should be possible to calculate how many amp hours are in the batteries. So this is the graph that I made. I made two measurements, one with the battery equalizer and one without. So this one is the one without the equalizer, and the current changes quite a bit depending on the load. It should be noted that positive current is when the battery is being discharged, negative current is when battery is being discharged. So looking at the voltage, the first thing that we notice is that at the start the batteries are all at basically the same voltage, whilst later, mostly here, they are at a very different voltage. However, they do seem to go back together at the end. I don't know why these batteries went up so much, these three batteries, instead of this one, because there is nothing special going on in the current graph. This might be that it just happens when they're more charged. We definitely do know and can see is that the voltage seems to be inversely proportional to the current here. So if it's being discharged, the voltage goes down. When it's being charged, the voltage goes up. And it is quite noticeable. For example, zooming in here, there was a peak of 56 amps when the voltage dropped to 12.86 volts, whilst when they were being charged at 24 amps, the voltage went up to 13.5 volts. Something that should be noted is that since this was such a long analysis, lasted roughly 5 hours, recorded it at a very low sample rate of 100 hertz, and there was a lot of noise on the measurement, and so to try to reduce it, I have used a low-pass filter on the measurement. There was also noise at about 15 kilohertz, which I would assume is from the switching DC-DC converter inside of the inverter. And so this is the test without the equalizer. Now we can see how the test with the equalizer looks. In theory, the batteries should be at a closer voltage, given that it should be equalized, but this does not seem to be the case to me, at least. Here it seems that this day we produced less electricity and less power went into the batteries, at least for shorter. Also the measurement is longer. Zooming in, we see always the same thing. When the batteries are being charged, the voltage goes up, and when they're being discharged, it goes down. It could be interesting to note that there is this curve, which is of course as the batteries charge and discharge. With the equalizer, the voltage of the batteries still went each of the batteries went at a different voltage at the end. If I change the range here so that we can see the whole peak, we can of course see that the second battery, which is the blue line, definitely went up a lot. And in this case, there was basically no charge or discharge. I would assume that this is because the blue line was lower than the other ones, and so the equalizer started charging it, and by charging it, it maybe charged it too much, or maybe the voltage is just higher because it was being charged, and so there was this very big difference in voltage. In the graph we also see these peaks here, and this is when the peaks in current should be when the water pump starts, and whilst here they may seem disaligned, they are, and it's just because these two graphs are shifted slightly, and if I align them one can see that they are aligned. So we can conclude that the batteries, of course, the voltage changes quite a bit when they are charged and discharged. At least from these graphs, I would conclude that the equalizer does not actually help. We can see that here the maximum difference in battery voltage was from 14.2 to 13.8, so that's roughly 0.4 volts. If we look at the one without the equalizer, the voltage difference seems to be from about 0.6 to 0.9 roughly, so it's a 0.3 volts difference. So it actually might be a bit worse with the equalizer. So in this case, the interesting thing that I would note is that at least in this part of the graph, it looks like the blue line is much more constant than the other two. This could be because the battery is different for one reason or another, because it seems to show a lower fluctuation in voltage when it's charged and discharged. I will probably keep the equalizer on the battery, but even if in the single test it seems to be maybe slightly worse, on the long run the batteries do dis-equalize, so I will keep it. That's all for this video, so thank you for watching and bye.